So delay nodes are ruining your life, and I'm going to tell you why. This is a big deal in multiplayer games. Usually you run into an issue, it's not working for whatever reason. You slap a delay node in there for a second, and boom, everything's going great. So I'm going to show you what the actual problem is and why the delayed node works, but why you also shouldn't be using it. It's an absolutely big no-no. So to demonstrate this, we're going to start out with a blank project 4.26.0. So make sure you're on that version or around that variant because, there can be little things that are different. So basically, it's a third-person project right here. Let's go ahead and get rid of this guy because he's going to cause some confusion. So just click on him and delete him. And then let's go to the third-person BP, go into Blueprints, and open up the third-person character. That's the character we just deleted, but we're going to spawn in anyway. So let me get that screen wherever the heck it went. So a little bit of lag there. Got our third-person character. It might start you out in the construction script, but we want to move over to the event graph. So click on up here. This is all the default crap they give you that we don't need. What we want to do is we're going to start out with a begin play. And so let's say you're starting out your game. Begin play is a good place to start. And the first thing you want to do is, let's say you want to get to your player state, because your player state's a great place to house things. So you're like, okay, easy enough. I'm just going to type in get player state. Okay, and now that you have your player state, we're going to go ahead and we're going to check if it's valid. Okay, so I got an is valid node. What that's going to do is that's going to tell us, okay, yep, you have the player state, we're good to go. So on one of the is valid nodes, we're going to just get this print string and we're going to type in is valid. And we're going to put that to green because green is good. Give it a 5 seconds. Okay, let's Control C and Control V that, and we're going to go over here. We're going to turn this red, or whatever the hell color that is, and say is not valid. Okay, so let's see what happens on this begin play, and we'll go from there. We'll do listen server for the first try. Okay, so let's see. Let's do a new editor window so it'll pop over, and it says is valid. Okay, so we're fine there. And if we were playing a single player game, that's fine. We'll do a second test. This time we're just going to put it as a client. And we're going to run 2 clients. Okay. So you could see client 2 said valid, and then client 1, it was not valid. So this is where your problems are going to start. So the guy who's just starting out, he's like, okay, let me just go what I know will fix this, and they'll throw in a delay node. So as soon as this stops loading, so they'll put in a delay node, and then they'll say, okay, a second, that should be good. Everything should be loaded in by that time. So we'll hit play. And like that, problem solved. Great, everything's valid. Let's move on to the next thing. Well, that'd be one of the biggest mistakes you could do. And what's going on here is it's just the player state isn't ready. Everything has to take an order. It takes a while for things to get what's called initialized. So things are loading up, and the more clients you have, the farther somebody is away, and a client is just another computer trying to connect to your server. So the farther he is away, just the longer things are going to go. So the problem with a delay node is you don't know how long to make that delay, right? So I mean, you could eventually start adding more and more and more time. You never really know for sure when you're going to be valid. So then what'll end up, long story short, you'll end up with a project with a ton of delay nodes. You'll never know when anything is initialized, and you'll be waiting 5 seconds eventually because you'll have, this is your character. Let's say you put a second on. Let's say your player state at once it starts out. You're wanting to do things, but you set things from your character onto your player state. Now it's got to be a delay, and you can see where I'm going with this, to where it's just endless delay nodes. You never know what's going on. So what's the solution? Now it is a somewhat of a time-based solution, but in the end, what it's really is, and I always pronounce this wrong, it's caching. It's caching or catching, whatever it is. It's basically, you're going to verify that what you need is there, and then you're going to save it. And we're going to do that utilizing a timer. And doing it this method, you don't want to do this all the time, but upon initialization, this is a perfectly acceptable time to do a polling method, as they would call it, because you're going to check until it's valid. And then once you're valid, you're going to kill that timer. So I've been talking a lot, so let me show you exactly what I'm talking about. So let's get rid of this delay node here, because that's just absolutely terrible. And then what we are going to do is we're going to set a timer. Okay, now if we were doing, if you're doing native C++, rather than set a timer with a specific time, you could do set timer for next tick. It's not a blueprint option, but that would be more like what you would probably see in the field if you were doing stuff. They would do it by the tick. That way, a tick does happen a lot, but this is gonna be firing it off pretty quickly. But anyway, we'll just use 0.1 for right now. And we're going to go ahead and make this looping, because we're going to want to loop every 0.1 seconds to check if that variable is valid before proceeding. So let's go ahead and hook this up to our begin play. Okay, and then what we are going to do over here is we are going to save a reference to this timer. So promote to a variable, and we'll call it our cache timer. Just like that. Now, an important note with these begin plays is that they could fire off multiple times. So what we want to do is we don't want to keep setting this timer if it's going to fire off multiple times at the beginning. You really can't rely on it. So what you need to do, let's bring out our timer that we just made. So it's set there. We're just getting it here. And we're going to say is active. So we're checking if it's already active. And if it's already active, we're not going to want to run it again. So let's press B as in boy, click left click to get our branch out there. And what we'll say is, hey, if you are already active, true, don't do anything. But if you're not active, then go ahead and set yourself. Okay. So we're looking pretty good there. Almost. I'll explain this in a minute. We just need to give it an event. Before I forget, though, anytime you're doing any sort of event, and in a fresh project, you're not going to have to worry about this, but I see this a lot. If you might be a child of a child blueprint, you don't know. So you should just get in the habit of right-clicking over here and add call to parent function. That way, if there is, and I'll do a whole video on just this, but in case you have a parent class, it's going to execute its logic first. If you were to make another child class and you didn't call parent, it's going to totally disregard all the other logic. That's a story for another day. I just want to make sure I'm showing you things the right way. So always make sure you got to call to your parent unless you distinctly don't want it for some reason. Okay, so we got this error here, and why is that? It's because we need to make an event. Now, we could make a custom event and drag off and have this long, nasty line, but we don't want our stuff to be ugly. So what we're going to do is we're going to drag off of here, and we are going to type in create event. Okay, and this nice little node pops up right here, and we are going to create matching event, just like that, and we're going to say check if valid, just for right now. Okay, so what are we checking is valid or not? Well, we're coming back over here. So let's see if that cleared up our error, and yes, it did. So that timer is going to now call this event, and it's going to be looping, so it's going to constantly keep looping. So if we're not valid, we don't want to do anything. We want it to keep executing. However, if it is valid, what we want to do is we want to take that timer reference that we had, and we want to clear it. Because we no longer want this to keep firing. Now, if you had a child class you were going to cast into to actually use this player state, and I might demonstrate that here at the end, we might want to cast into it first to make sure it succeeds before clearing this timer. But either way, let's do that. And if it is valid, usually off these check if valid events, you would have a separate event. So let's go over here and just press period, period. And that is going to add a custom event. And then we would say catched variable, if I could spell. Okay, and you might have a million different things that you're catching right now. So you might have a player state, I don't know, some other thing. You want to make sure it's valid, so you're going to let it go through this whole string of events right here, this check of invalid events, and then when your check variable's ready, fires off, it's going to practically become your new play or whatever. So let's go ahead. Let me go over here. Let's see where we're at. Let's save what we got. Let's press play. We got our 2 clients. Okay, and everything is going valid. It's not constantly printing the strings, so you know that the timer stopped like it should have. But we never had anything go invalid, so I want to make sure we have that demonstrated here. Okay, so you can see what happened here. It was valid for some, and then it was invalid for others, and then it eventually went valid. And that's the exact sort of thing. I probably played this through, I don't know, like 10, 15 different times, and sometimes perfectly valid. Other times it just wouldn't. They wouldn't go valid, and we had to rely on that timer. So these are the sort of mysteries that when you're playing around and you're banging your head against the wall, why doesn't it work? It worked last night just fine. Well, let's say your computer's bogged down. Let's say, or you start, you got a cooked build or something. Okay, there's a perfect example. You get a cooked build, and all of a sudden it's not working because you're in a real networked environment. Okay. And we got all these problems. Well, it's because you're not caching your variables. You're not you're using a delay node that may or you don't know when it's going to fire off. So that's pretty much the gist of what I wanted to show you. To those who are new to Unreal or whatever, they want to know what the heck a player state even is. Well, right now we're in the character itself. If you had a player state, you would use it to access variables that you want to persist outside of the character. So let's say your character died and you had an inventory and you wanted to store some of that inventory. Well, it would make a lot more sense to hold it on your player state, or even your health, even though that's per character. It would be, if you don't want to have to keep remembering or passing along this data from one character to another. It's easy to store it in a place like a player state. So that's why I use that as an example. But like I said, to those who haven't used it, just real quick, how you would even make one is you just go over to your blueprint class, because there's one they give you by default. Anyway, just click the drop down on all classes. Go into player state. Click it right there. Select there. And just say, name it whatever. Then you got your player state. And then in here, wherever that opened up, I got like a million monitors going on. I got to track it down. Oh, right there. Okay, so you could put in here, let's say, a variable like health. And you could change it to a float because that would make sense. Okay. And the great thing about this is, like the character, all the other players have access to this health. So then what we would need to do is go into I think it's your project settings. Let's check into here. Oh, that's what it was. Okay. So in your project settings, game mode, you can change your player state here, and this will make the defaults. You can do this per level, but we'll just do it here, and we'll give it the new player state that we have. Generic player state, just so you guys know, that's just the native class. That's all. So now we've made a blueprint class that inherited from player state. So it has everything that the original player state has, plus our brand new logic. So then you can go into your character. You can get this player state, which is the native class, and cast to the marked player state. You can get your health out of there. Okay, and now that instead of it is valid, it's going to go ahead and it'll print out. Oh, that's our duration. We don't want to do that. We want to print it to our string here. Get that off of there. Okay. And so in this instance, if I wanted to make sure that the cast succeeded for whatever reason, I could go into here in my is valid, have it right into here. So I was rewatching this video, and I did a lot of talking about caching variables and all this crap, and I didn't even do it like where I really wanted to do it, which was right here. So I'm going to move myself like this. Hopefully it records me moving across the screen. And here, I'm going to try this with this hand right here. Okay. You see that where it says as marked player state? Right click onto that, promote it to a variable, and then save it. That way, after this, we're going to have an event that's for catch variables ready. And then you always have a reference to that casted player state. So you don't have to cast. I mean, this is still a necessary check, right? We got to make sure our player state is valid. And because it's valid, the cast will succeed. It's fine. But we really should save it to save ourselves the trouble of having to cast to this child class. Anyway. And then we should start to see 100s, because then we know we're actually pulling the value that we want. So let's just press play real quick. Okay, and now we got our hundreds. And once again, we had a 1 is not valid, which is yet again why we're doing this whole method of polling until we're sure that it's valid. I know some people are going to say right away, well, that's expensive. Well, this is really the time to do it upon initialization, or these sorts of things. That's why there are extensive loading screens at the beginning of your games and things like that. It's just the way it is. It's one of those things you really can't get around. And now you'll find some classes already have events in them that'll say, you know, a delegate or something you can bind to that will, you know, help you along if it's a developed thing. But I'm saying, like, this is a blank project. You're just starting out. You're going to have to make things like this just until you get going. Oh, and another thing, you might be wondering, why are we seeing so many print strings? Like there's like here, I'll put an example. It was like client 1, millions of different things. Well, that's because the player state exists for each character on each client and server. So let's say you have 2 clients, so you're going to see a server, a client, and another client, and each client's going to see a server itself and the other client. So that's 3 things for each. So that's 3 times 3, which would be 9 different things. So that's why you're seeing, you know, you'll see one null, one that was not valid out of all that whole string, was because it was probably one client not seeing another client's player state, which would be why, hey, I see my health. Why can't I see the other guy's health? Well, because early on in the thing, it was null. So that's an important thing to remember as far as how the world goes. And you can see each of these things. So like let me put once we get, let's see, once we get in, let's put one way over here. We're going to press F9. That'll give us a breakpoint. And to give you an idea of how many different things are in the world, which one of these succeeds? Okay, we got one that succeeds. Okay, and right now you got a third-person character 1, third-person character. You got one on the client, one on the server. And as you can see, as things start to load in, we're going to have more and more things. Let me just go to no debug. Okay, as you can see, it's growing. Let's just press play a few times. Okay. And as you can see, each one is going to be checking each player state, if that makes sense. And furthermore, each begin play, it's getting called on all clients and servers. So that's getting called multiple times there, in addition to just being called multiple times for every single client and all servers. Okay, so let's talk about, in general, when you should use a delay node, because they do have a purpose. They're not just evil. It's just their purpose isn't for usually initializing events. That might be for you want a specific delay, like, I don't know, before, let's say you play an animation, you play the animation, you get the time remaining, you might, and then at the end of that animation, you might execute something. Usually it's things that are cosmetic in nature, like let's say you want a splash screen to remain on for, a certain amount of time and you want it to go away. Any one of these number of things. But nothing that you don't know the answer to should be the delay node should be the solution for. Now, another interesting thing with the delay node is the retriggerable delay, which if you do end up using delayed nodes for whatever, just know that if you did something like this, this would be very bad if you were, say, going through it for each loop. Let me compile that. This would be really, really bad because delay nodes ignore anything that comes at it again while it's operating. So let's say you had this delay node going for a second and you were doing a for loop. It's going to hit the first time and then it's going to ignore all the others. Retriggerable delay is different. It restarts that delay. So you might only get the last one if I'm thinking right. But they do work differently. Perform a latent action with a retriggerable delay. Calling again while it's counting down will reset the countdown to duration. So it's interesting to know the differences between the delays if you go about using them. Like I said, they're not bad. You just know their proper place. It's just a common thing that designers do. Well, they'll get crazy with the delays. Now, hey, a good thing to check if maybe you're having initialization issues would be to, before going through the trouble of setting all this up, to put a delay in there, something ridiculous like 5 seconds, so you know whether or not for sure that, okay, it is a timing issue. I need to set something up to loop through here. So if you guys have any questions, just post them below. I'm sure this one will generate a lot because it's it's one of those things that I'm sure people will have some opinions on. Oh, really, really important with this timer also. You do have to make sure that you clear it, because the one bad thing that could happen with these, if you don't clear the timer, this thing's just constantly going in the background, and that can be really expensive. Depending on what you have on the check is valid line. So really make sure that you clear these out as soon as possible. Anyway, that's all I have for today.